Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, in continuation with your main topic, we are going to take the last segment of it. And here, what we are going to learn today is how to find the angles between two intersecting lines. So let's begin. After completing the very lesson today, my dear student will be able to find the angle between the two intersecting straight lines. This is what I hope you'll be able to do after completing my lesson today. So as usual in your favorite segment of the lesson, that is Mars says fun, today I'll give you the last property of this binomial expansion of the Pascal triangle. Last property of the Pascal triangle, and there is the how to use the Pascal triangle in the binomial expansion, which is very, very vital while doing this binomial expansion. I will show you what we need to do in order to use the Pascal triangle in this binomial expansion, and that will be done after completing my lesson today, so don't go away. So to begin in the lesson, what we do first is to learn how to find the angles between the two intersecting lines. So if the angle is theta, this is the angle that is between the two intersecting lines, and those two lines have slope m1 and m2 respectively. So the angle theta is given by this simple formula. This is the formula to find the angle theta. So it says theta equals to tan inverse of open bracket inside the bracket. You now have m1 minus m2 all over 1 plus m1 m2. This is the formula we now used to find the angle theta, where we just substituted this respective slopes of the two intersecting lines m1 and m2. These are the only things we now substitute and simplify, and then find the tan inverse of the simplified form of this very bracket. That will give you the angle theta. We are going to take examples how we can make use of this formula and find the angle between two intersecting lines. So let's just move. Example number 1, it says find the acute angle between two lines whose slopes are -3 and 2 respectively. So we have two lines that have these very slopes, and we ask to find the acute angle between those two lines. So solution to this very problem, we write down the formula for finding angle. If that angle related theta, so the formula for finding angle is says theta equals to tan inverse of open bracket. You have your m1 minus m2 all over 1 plus m1 m2. So you now find what is your m1, what is your m2. Remember, m1 m2 are nothing but the slopes of those two lines. So if you related the very first slope to be your m1, then the second one will now be your m2. So it is those two slopes that you are going to substitute in here for m1 and m2. So substituting m1 by -3 and m2 by 2 correctly, you now have tan inverse of open bracket -3 minus 2 all over 1 plus -3 times 2. So there we continue. The numerator -3 minus 2 simply gives you this -5, and the denominator there you have this multiplication first. That is -3 times 2 will give you -6. So you have 1 minus 6. And subtracting 6 from 1 will give you another -5. So you have tan inverse of open bracket -5 over -5. -5 divided by -5 simply gives you 1 positive. So we are now finding tan inverse of 1. If you use your calculator correctly to find this tan inverse of 1, what you are going to have is now 45 degrees. So the angle between these two lines is now 45 degrees. Let's just take one more example. Example number 2, we asked to find the angle theta between the two lines, and those two lines have slopes 2 and 3 over 4 respectively. Solution to this very problem, writing down the formula for finding angle theta between the two lines, which says theta equals to tan inverse open bracket inside the bracket is m1 minus m2 all over 1 plus m1 m2, where m1 is the slope of the very first line, which is in this case 2, and m2 is the second slope 3 over 4. So substituting those correctly, you now have theta to be equals to tan inverse of open bracket 2 minus 3 all over 4 divided by 1 plus 2 times 3 over 4. I have replaced the m2 by 3 over 4 and the m1 by 2. So simplifying what is in the bracket correctly, starting with denominator, that is 2 minus 3 all over 4. Subtraction of these two fractions give you answer 5 over 4. And the multiplication here at the denominator level, that is 2 times 3 over 4. You can see 2 in 4 will be 2. So you have nothing but 1 times 3 over 2, which is 3 over 2. So next I'm going to do is to add these two numbers there at the denominator level. So I'm going to have a tan inverse of 5 over 4 is your numerator, while this 5 over 2 is the addition of 1 and 3 over 2. That gives you 5 over 2. I have changed this over to this division sign. So I continue. So dividing by fraction means multiplication by the reciprocal of that very fraction. So I'm going to have a tan inverse of open bracket, you have 5 over 4, which I just copied. Then times instead of division, you now have 2 over 5 instead of 5 over 2. So there we continue. So simplifying this 5 will cancel 5 and 2 in this 4 will now be nothing but 2. So in the end, you now have tan inverse of 1 over 2. And the tan inverse of 1 over 2, if you use your calculator correctly to find out this tan inverse, what you are going to have is now going to be 30 degrees. So this is the angle between the two lines with these two slopes. That is with the slope 2 and 3 over 4. With these two examples, I have come to the end of this very lesson, my dear students. I hope you find it resourceful. We'll see another new topic in our next lesson. Thank you for your attention, and let me just move to the last segment, Mrs. Fan. So another interesting property of the Pascal triangle, which is very, very useful, like I have said in the binomial expansion. It says the elements in a row in this your Pascal triangle are just nothing but the coefficients of terms in your binomial expansion. So this is your Pascal triangle. If you ask to expand, for example, this binomial expansion x plus y raised to the power of 2. If you do this expansion, this is what you are going to have. It will be x squared plus 2xy plus y squared. You can see the first term here, the coefficient of x squared is 1, which is this very one. The coefficient of xy is this number. Let me take another binomial expansion. Suppose you ask to expand this x plus y raised to the power of 3. If you do it correctly, this is what you're going to have: x to cube plus 3x squared, y plus 3xy squared, then plus y cubed. And looking at the coefficients of this, the terms in this binomial expansion is exactly the elements in the fourth row. Look at 1, the coefficient of x cubed; 3, the coefficient of x squared; y, look at it here; and 3, the coefficient of xy squared. Look at this 3. And the last term, y cubed, its coefficient is 1. Look at it here. Let me just take one more. If you are now asked to find the expansion of this x plus y whole raised to the power of 4, if you did correctly, this is what you're going to have. And this also the coefficients of those terms here. If you check carefully, to give you those elements in this fifth row. So this Pascal triangle is now used to determine the coefficients of the terms in your binomial expansion. Thank you for your attention. We'll see you in our next lesson.